Hello everyone. Today we're going to talk about a base Maven project for development in a Java programming language. What is a base project? It is a sample Java project with popular choices of build tools, dependency management tools, configuration, tests, and overall coding practices. You can clone it from GitHub, modify it to your needs, and focus on writing business logic for your application. Why is there a need for a base project? The project makes informed choices, for example, of code coverage with unit tests. If choices are not made, then code quality and development speed eventually suffer, hurting business goals. Overall, it is about introducing restrictions which allow us to avoid the chaos and move fast in a chosen business direction. Still, only a possible set of choices is shown in a sample project. Your organization might benefit from a different set of choices. For example, you may choose to enforce the contract-based testing right from the start, or settle on the code coverage with unit tests at a level of, say, 90% and not 100%. In this presentation, I will show those choices and practices and explain why those were implemented. We'll start by building the project, then I'll show you how to run it, and at the end, we will discuss in more detail the choices made. Let me first point out that one of the project goals is developer productivity. One should be able to get up and running quickly, have an integrated development environment, and produce an app that anybody else in the team can readily execute. The proposed setup helps you achieve just that, and you need to focus only on business logic. The setup is universal. It works on Mac OS, on Windows 10, and on various flavors of Linux. Let's do the building and running part. So I assume no software installed on your computer, so we'll install everything together what we need. First, you need to get the code to your local machine and manage it. Effectively have a version control software. The version control system of choice in 2020 is Git. So the setup consists of a repository in GitHub, plus Git software installed on your machine to seamlessly manage code within the version control process. You can install Git from this link. It's available for all major operating systems. Let us install Git. Open your browser and search for download Git. Navigate to the link on git-scm.com. We're going to install it on Windows, so click here on Windows. The installer is going to download. Then click on the downloaded file. Say yes that you want to install it. And, well, choose all the defaults. In several seconds, you will be done and the Git client will be installed on your machine. Let's wait for it to finish. Well, congratulations, you have a Git client on your machine now. Next, the code of the base project is written in Java. So you need to install a Java Development Kit, or JDK for short, to compile it. Open your browser and search for adopt open JDK. Navigate to adoptopenjdk.net. Choose OpenJDK 11 LTS version choose a hotspot JVM. Click on latest release to download the installer. Then run the installer. Accept the terms of agreement. Here in the custom setup step, it's very important to choose to set Java home variable. It will really help to integrate Maven with Java. After you chose to set Java home variable, click on Next, Install, and in several seconds you will be done. Congratulations! You have Java 11 64-bit JDK installed on your machine. Then you need a way to edit and write code. A common text editor can get the job done, but it's not the best choice. We will typically write code in an integrated development environment, or IDE. Two most popular Java IDEs are Eclipse and IntelliJ IDEA. I choose IntelliJ IDEA for this tutorial. I personally use the paid Ultimate version for professional development, but I will show all the walkthroughs with the free community edition. It makes a rather little difference. Let us install IntelliJ IDEA Community Edition. Open your browser and search for IntelliJ. Open the download page on jetbrains.com. Click Download under the Community Edition. Save the file. Let us fast forward. Open the saved file. Allow it to run. Click Next a couple of times. You may want to place a 64-bit launcher on your desktop and choose File Associations, essentially with all proposed file extensions. Click Next and Install. Let us fast forward as well. Congratulations! Now you have IntelliJ IDEA 2020 Community Edition on your machine. Now you can handle code and a place to store it. But Java is a compiled language, so you need to have some place to store and handle those compilation results. Traditionally, the compiled class files were packaged with jar dependencies into a big war archives or big jars, which were then deployed to a web server or executed directly. However, then execution depends on the version of Java Virtual Machine, on the version and the settings of the web server. A more recent trend is to make those executable packages even more independent, isolated, and self-sufficient, with everything baked into them with the exception of a small set of configuration options. It's going to be like a mini operating system. Then one deploys such a package into various environments with minimal hassle, truly living up to Java's value proposition of compiling once and running everywhere. Well, Docker containers is the mainstream choice for such packaging, with Docker Hub being the most popular public storage for Docker containers. You need to install Docker Engine on your local machine to manage those images. After you install it, you need to start the Docker Engine. Let us install Docker Desktop on your machine. Open your browser, search for Docker, click on a Docker Desktop link on docker.com, click on a download for Windows or for Mac if you have a Mac. and click on that button Get Docker and save the installer. Open the installer, let it run, and just click OK. Docker on Windows needs a Hyper-V virtualization. The installer will try to enable it if it's not enabled yet. Congratulations! You have a Docker desktop installed, and now you can manage and run containers on your local. Well, now you have all 4 tools installed. So let's check out the code from the public GitHub repository. Then we can compile it and run it on our local machine. Now you have Git, Java, IntelliJ IDEA, and Docker Desktop installed on your local machine. Let's check out the public GitHub repository with the base project, compile the code, and run on a local machine. Open your browser, go to github.com, search for Romanastar, which is my username. Click on code, and then you will see here the base project Maven link to the actual project. Click on that, click on the green clone or download button, then click here on the copy pictogram. Now start IntelliJ IDEA and click on Get From Version Control. Just paste the URL you just copied and click Clone. After several seconds, the project will open in IntelliJ IDEA. So you should be able to browse the code here on the left side under the Project tab. Now it's time to set up everything we need for Docker. Let us start Docker Engine. If you have not yet done so, just double click on it. And when it's started, it's gonna show you here the icon in a tray with a bunch of options, and it's gonna tell you that Docker Desktop is running. Then let us ensure that you have an account on Docker Hub, where you will store Docker images and integrate that with the Docker client and with IntelliJ IDEA on your machine. Open your browser, go to hub.docker.com, then sign up for an account if you have not yet done so. I already have an account, so I can click on Sign In and log in with my username, which is Romanastar, and with my password. You need to remember that username you have. Next, you'll need a terminal on your computer to run Docker commands. Luckily, a terminal is always available from inside IntelliJ. So open IntelliJ, then go to View, Tool Windows, and the Terminal. Or simply click here on the word Terminal in the bottom. In Terminal, you can type Docker, login, then enter the same username and password as you used on Docker Hub. Well, congratulations, you have logged in to Docker Hub from your local machine. And here you could see that the Docker desktop has picked up the same credentials, Now it tells you that you are logged in as Roman Astor in my case. Next, you need to figure out which Docker credential store your operating system uses. In your browser or in any file system explorer, navigate to your home directory. And I can do it in the browser directly in Windows by typing file, C, users, and then choose my username, which is Roman. On Mac and Linux, the shortcut for a home directory is simply a tilde. So once in a home directory, open .docker subdirectory and look at the content of config.json file. So in a browser, you can simply click on it, and a JSON file will show. You can check that the cred store here has the value of desktop. So credential store / credential helper for Docker is desktop in my case. In Mac OS, a typical value for cred store is OSX keychain. You'll be able to discover that by yourself on your machine. So now what can you do with it? Well, go back to your terminal and type docker -credential the name of that helper, which is desktop in my case, space list. It's going to tell you that you have signed in to Docker Hub Docker repository, which is index.docker.io, with username Roman Astor, or with your username. Well, you already knew that, but what is less trivial is that you need to tell Maven the type of the Docker credential helper. In IntelliJ, navigate to pom.xml file in the top directory, which is also called the parent pom file. So double click on it and find the line which has cred helper in it. So here you could type your credential helper. On the Mac, you would type OSX keychain, but we are not on the Mac here, so the desktop is the appropriate value for Windows. At this point, you have integrated a Docker client on your local with IntelliJ and with a Docker Hub account. However, you can't yet create and push images to Docker Hub since the base project setup points at my username, Roman Astor, and well, you don't have permissions to push images under my repositories. So we need to repoint that to your account. Let's fix that. Let us open the pom.xml file inside of the demo directory. This is not the parent pom, this is specifically the pom file inside of the demo directory. Then search for line with index.docker.io, and here this is the address where your image is going to be published. So instead of Roman Astor, switch to your own username, whatever you registered with on Docker Hub. And you also have a chance to modify the repository. Instead of base project Maven, I should say my test, something else. I would say base project Maven is good enough, probably. Then you can also modify the image tag, which goes after the colon. You can see 2.0 or 0.1, all up to you. Well, you can now save that file. I'll keep it at Roman Astor for this demo. We are ready to build the project and push the image to the public repository. Be careful though. Don't upload Docker images to public repositories if your company policy prohibits you from doing so. Assuming that you are allowed to proceed, let us proceed. The base project repo comes with Linux and the Windows executables mvnw over here. This stands for Maven wrapper. Maven is a build automation tool which does a lot of things for build orchestration. The power of Maven is in its plugins, which we will discuss in a bit. For now, let us compile the project with Maven wrapper. There are several ways to do so. We'll discuss more ways in later stages. But for now, let us just run the command line from a terminal. So open the terminal, then type mvnw space clean space install /p image -build. If all previous steps executed successfully, then Maven wrapper will be able to download Maven, compile the code, assemble it into an executable jar, create a Docker image with the jar file, and push it to Docker Hub. You see that the image has built successfully and that the image was pushed at this address. Let's find the image in the Docker Hub. Let's go to hub.docker.com. Log in with your username. I'm already logged in as Roman Astor. Here you could see base project Maven repository, and the image with tag 1.0 was updated just a few seconds ago. This is indeed the image which we have just pushed to Docker Hub. Congratulations! You published your own image on the Docker Hub. As the last step of the setup, we'll run the Docker container and check that it works. Let us open the terminal in IntelliJ. Open IntelliJ and click on this terminal button. In the terminal, execute the docker command. Specifically, docker space run -p 8080 :8080 -rm -name Maven, and the address of the image Roman Astor /base project Maven :1.0. Here I use my location on the Docker Hub, my username and my repository, base project Maven, but you can switch to your username and your repository and your tag as well. It should work either way. Let us execute the command. It's downloading the image, and once it downloads that, it's gonna try to start it. You see logs showing up in the console, and eventually it's gonna say started demo application. Well, that means that the application is alive and ready to serve traffic. Let us go to the browser and check that the health check URL reports the results. Type localhost 8080 /actuator/health. You're gonna see status up JSON response. Congratulations! You have fully set up the demo application. Let us now talk about the choices which were made for this project. In the previous section, we discussed running Maven wrapper to orchestrate building the application. Let us now talk about Maven in more detail. Apache Maven is a build automation tool which enables a smooth progression through all of the build steps: finding and downloading dependencies, collecting application resources, compiling the code, running unit and integration tests, packaging the compiled code, building and uploading Docker images. There is another popular build automation tool for Java apps, Gradle. Gradle appears to be more versatile and flexible. It's somewhat easier to do customizations in, thus it is often suitable for large projects. However, Maven has more plugins available and more examples online on how to get things done. Maven has a wider community support. Thus, Maven is a tool of choice for small to medium-sized projects. Exactly the type of a project we are creating. IntelliJ offers great integration with Maven. We have used the command line to do the compilation, but you should get familiar with a Maven tool window. Let us open Maven tool window. Open IntelliJ, go to View, Tool Windows, Maven, or you can simply press on this Maven button on the top right. You should be able to select individual profiles to execute. We'll talk about the profiles later. They run different build phases in here and execute individual plugin goals. To learn more about Maven, read, for example, about Maven lifecycle. Open your browser and search for Maven lifecycle. And click on the first link. It has plenty of reading about Maven. Let's go back to IntelliJ and see where Maven magic happens. It happens in project object model files, also called the POM files. They contain build and project configuration details, such as information about plugins and dependent libraries. The base project has POM XML file in the root folder, this one. That's the so-called parent POM file. There's also a pom.xml file in one of the directories. Demo directory, so this file. The demo is a module of the application, defined in a parent POM XML, here as a module with the name demo. The child POM XML inside of the demo folder refers to its parent. In fact, it has a parent to be that parent pom.xml, and we can navigate between the parent and the child. The build configuration is split between the parent and the child POM. What kind of configuration would you put in a parent versus in a child? The parent POM contains general items needed for the whole project. For example, properties. The Java version number, the encoding, the versions of the dependencies, the versions of plugins, and the auxiliary flags. Parent POM would have a dependency management section where we specify which dependency versions the child modules should use. But the child modules will still need to explicitly declare those dependencies. This is done to use uniform versions for the entire projects. The versions are only defined here in dependency management section. Next section is profiles. Those are the bundles of properties, plugins, and dependencies to be used together for a particular type of a build. For example, by activating the profiles, one can choose to run or not to run the unit tests. Probably the most interesting section of the parent POM is the build section. It defines which plugins and plugin configurations can be used by the child modules. Specifically in the plugin management section. Let's now look at the child pom.xml. Here, instead of dependency management section, it has the dependencies section, which defines the actual dependencies to be used by the module, but without the versions. We can navigate back up to figure out which version is to be used. A build section specifies the actual plugins to be used within the module, again without the versions. The versions are defined here in a parent pom. Note that the most plugins, the configuration can simply be defined in the parent pom in the plugin management section, and then we only need to declare the plugin itself in the plugins section. However, for some plugins, we can define extra configuration in the child pom file. That's the basics of the Maven project object model. Let's talk about Java. Java version selection deserves special attention. We chose Java 11 for this project, but didn't really explain why. The latest Java version as of today is Java 14. It can be readily downloaded and utilized. Yet, we chose version 11. And there is a good reason for that. When writing enterprise applications, the duration of support plays an important role. Support means fixing bugs and making security patches, which keep your application secure on your platform of choice. So Java 11 is supported by its developers till 2024, while Java 14 falls out of support in October of this year. So the next Java long-term support version is Java 17. When building a Docker image with embedded Java, it is relatively easy to update the Java version, because you don't have to physically install Java on your production servers. However, there is still a risk that with a new Java version, some part of your application would break, require development cycles to fix, so it's a pain with a little gain. Thus, companies would often choose the safe route of upgrading only to long-term support versions. So we chose to write an application in Java, which is the de facto standard for enterprise software development. When writing business application in Java, we typically make heavy use of the frameworks, the codes already written by others to solve common business problems or technical challenges. For example, how to conveniently connect to the database, how to manage fallback and retries. The frameworks reduce boilerplate code, allow to reduce mistakes, and overall accelerates the development and make it more convenient. Spring Framework is probably the most popular one. It allows setting up the base application with a minimum of code. We also use a Spring Boot version 2, which is the solution on top of Spring Framework, and other libraries which are tested to work together. Spring Boot allows to have a running application with a bare minimum of code and configuration. But it's very powerful and allows to extensively customize itself when needed. We declare Spring Boot dependencies as a POM type of dependency in a parent POM file. It's a special way to specify all dependencies and all versions which constitute the Spring Boot. At this time, it's more than 550 dependencies. That's a lot. Then in a child POM files, you can declare those dependencies without the need to specify a version. And those dependencies should work together without problems. So we mentioned Maven, Java, and Java frameworks. Now we are ready to dive deeper into Maven plugins. We already saw that the parent POM defined lots of plugins and their configurations. But what are those plugins and what do they do? Let's go over them one by one. Maven Compiler plugin facilitates compilation with Java compiler. It needs to be explicitly included to specify the Java version. Specifically, Java 11 is what we use. Maven Surefire Plugin enables running unit tests. You can see that Java test classes with all the names except those ending at integration test are considered to be the unit tests. Maven Failsafe Plugin enables running in integration tests, which by convention are defined in Java test source classes with names ending in integration test. There is a subtle difference between those two plugins to run tests. Surefire plugin fails the build if any of the tests fail, while the failsafe first runs the tests and then optionally checks if the tests passed. Next, Jacoco Maven plugin enforces code coverage with unit tests. It is a de facto standard in 2020 to enforce unit test coverage. So not all classes need to be covered with unit tests. Some of the classes contain just a boilerplate code. Those classes with names ending with application and configuration are thus excluded from code coverage check from the reports because those are the ones containing lots of boilerplate code. Let me show you one trick. After you execute unit tests and run Jacoco plugin to check unit test coverage, navigate to demo-target folder, then open site Jacoco folder and right-click on index.xml file and say open in browser. You'll get the coverage report in HTML where you will clearly see any gaps in coverage. And I will talk more about unit and integration tests in a bit. Next up is Maven Checkstyle plugin. It enforces the code style. Out of the box, it offers a modern Google checks.xml style, which we chose to adopt. It is a relatively strict configuration which we implemented. It fails to build on minor style violations. It would be a lot of hassle to manually check all minor problems and fix them. Then, wouldn't it be great to have the code formatted automatically into the style we need? Well, the IntelliJ IDEA offers just that. At first, you need to download the IntelliJ IDEA version of code style from the internet. Open your browser and search for IntelliJ Java Google style. Open the link from the GitHub, and this is the style file. Click on the raw button to get the actual file and save. For me, it's just Ctrl S. So save on your disk. Then go back to IntelliJ IDEA, go to File, Settings, Editor, Code Style, Java. Click on this gear icon, then Import Scheme, IntelliJ IDEA Google Code Style, and on your file which you have downloaded. So that's it. This is the Google style. And now IntelliJ IDEA can format the code for you. Let's try it out. Open the file located under demo, src, main, java, and this long package name, controller, and a sample controller. Introduce a couple of spaces in various places of the code. Then go to Code, Reformat Code, and magic happens. The IntelliJ IDEA removed all the spaces and returned the code to a compliant state. So you can use the keyboard shortcut as well. It's Ctrl-Alt-L under Windows, Shift-Alt-L under Fedora. Note that the Google style is a bit unusual, since it has indentation with 2 spaces and not with 4 spaces, which does take a little bit of time to get used to, but it saves space. Spring Boot Maven plugin facilitates building an executable Uber jar file for a Spring Boot application, which contains all classes, resources, and dependencies. You can run it simply on a command line. Let us stop the Docker container we started and run the executable jar file. Open the Docker desktop application. It's hiding here in a tray for me. Go to the dashboard. Here's that Maven container running. So stop it. It's taking up the port 8080. Now port 8080 is free. Go to IntelliJ and open the terminal. Change directory to demo/target and execute java-jar demo-1.0-exec.jar. You could see the familiar logs and the statement that demo application has started. Let's go to the browser and check the health check. It's located at localhost 8080 actuator health. You can see that the application is running and status is up. Let's go back to the IntelliJ and press Ctrl+C, which simply shuts down the application. So now, if you refresh the health check, then it's going to fail because we stopped the application. However, the main outcome of the build is not this executable jar file, but a Docker image. The Java Maven plugin enables building Docker images and does that without an explicit Docker file. Everything is defined inside of the POM files. Configuration of the Java plugin includes the base Docker image with Java. We let Maven download this base Docker image from Docker Hub. But how do we uniquely identify the right base image? In fact, if we specify the name and the tag combination, then Java plugin issues the warning when it says that this combination might not necessarily uniquely identify an image. Instead, it's recommended to define the starting image by its hash, which is what we did. It is a little verbose, but it does the job, especially if you leave a comment with the desired name and the tag combination to know what kind of image we're getting. Configuration for this plugin uses the credential helper, which we already saw when we integrated the Maven with the Docker engine. The Java plugin configuration is split between the parent POM file and the child POM file. We define the base image in the parent POM to make sure to use the same Java base for all of the projects. But in the child POM modules, we also define some configuration. So this configuration includes everything specific to individual applications whose code is stored in those modules, such as the image name, the port mapping, and everything else needed. Well, this concludes the discussion of Maven plugins. Feel free to modify and experiment with the config. Let us discuss the types of test and test coverage. We have two types of tests in the project. the unit tests and the integration tests. Let us open a unit test file. Type Ctrl-N to search for Java classes and type sample controller test. In this class, just like in other unit tests, we check functionality of a class in isolation and mock all of its dependencies. We use assertions with assert j to check the method outputs and the side effects against the expectations. We don't initialize the entire application to run unit tests. Those can be executed fairly quickly. The integration tests are different. Let us open an integration test file. Do Ctrl-N again and select Sample Controller Integration Test. We can see Spring Boot Test annotation. Spring Boot helps us to initialize the entire application, but in a test mode, running a web server on an arbitrary port, and providing a way to make calls into the application as if they were made from the outside. In integration tests, we check the functionality of the entire application, or a big chunk of it. They require an application to be started, and check the application functionality as a whole. Integration tests take longer to run. There are fewer of them. Well, what type of tests do we need in the application? We need both. The unit tests to ensure that our application is clean, clearly written, and does what it needs to do at its lowest scale. The integration tests to ensure that our application functions correctly as a whole and performs its business functions. For the unit tests to be of maximum use, one needs to enforce the highest standards of the test coverage. Navigate to the configuration of the Jacoco Maven plugin in the parent POM. As you could see, it requires the minimum coverage of 100% for every line of code, and also 100% for every logical branch. It seems hard at first, but the discipline of maintaining 100% instead of, say, 90% coverage pays off. One really starts to think about the unnecessary and impossible code, making the code shorter and clearer. The classes with the boilerplate code can be excluded from the unit tests coverage requirement. There is not much of a need to include integration tests in code coverage. Integration tests mostly execute happy scenarios, only exercising a fraction of code. It would take quite a bit of time to create the integration tests, which cover all possible scenarios, and then the tests would take hours at best to execute. So we leave the code coverage requirement only on the unit tests. Lastly, let us talk about Maven profiles. Open the Maven tool window. The profiles here at the top are depicted as checkboxes. You see 3 profiles, and one of them, unit tests, is already checked by default. Unit tests profile toggles execution of the unit tests and checking the unit test code coverage. Integration tests profile toggles execution of the integration tests. The last profile, image build, toggles creation of the Docker image and publishing it to Docker Hub. Thus, we have an option to not create or publish the Docker image in a Maven build. We have already exercised image build profile from the command line when we executed Maven with -P image build command line option. Note that each profile performs independent actions and can be toggled independently of any other profile. That's it for the Maven project. Feel free to experiment with it and improve it. The PRs are welcome. It's entirely up to you which direction to take it. Hope you find the choices made in the project and the discussion in the video to be helpful. Enjoy!